Let's say you're a junior quality control engineer for Just Corks Incorporated. There are 2 machines available for cutting corks, and those corks are intended for use in wine bottles. The first machine produces corks with diameters that are normally distributed, with mean 3 centimeters and standard deviation 0.1 centimeter. The second machine produces corks with diameters that have a normal distribution with mean 3.06 centimeters and a standard deviation of 0.05 centimeters. Acceptable corks have diameters between 2.95 centimeters and 3.1 centimeters. Which machine is more likely to produce an acceptable cork? Okay, so we have 2 machines. One produces corks that have a slightly higher mean, but it has less variability. So which is going to be better for us? Okay, the one with the lower mean but higher variability, or the one with the higher mean and lower variability? Okay, so let's look at these 2 machines. Here's machine 1, okay, and let's say that random variable x measures the diameter of corks from machine 1, okay? And x is normally distributed with a mean of 3 centimeters and a standard deviation of 0.1 centimeter. And here's machine 2. It has a random variable y that describes its diameter, okay? Diameter of cork from machine 2, and this is in centimeters. Of course, this is also in centimeters. And y is normally distributed with mean 3.06 centimeters and a standard deviation of 0.05. Okay? So which produces corks that are better for us, for our purposes? And we have specifications on what those corks need to be. Okay? The lower bound on an acceptable cork, 2.95 centimeters. And the upper bound is 3.1. Okay? Anything above this and below this, we can't use. So this is the probability that we want. We want to maximize this probability. Okay? So this is for machine 1. Let's find out what the probability is that we produce an acceptable cork. Okay? We can convert this down to a z distribution, okay, with this calculation, 2.95 minus 3 divided by 0.1. Okay? Likewise up here, this is 3.1 minus 3 divided by 0.1. That is the probability that z is between negative 0.5 and 1. Okay? So we can go look this up in our standard normal distribution table. We love it. If we go look up this area right here, between 0 and 0.5, this gives us this area right here. Okay? That area happens to be 0.1915. And if we go look up the area between 0 and 1, okay, we get a value that is 0.3413. So the probability that x is between 2.95 and 3.1, this area right here, the probability of an acceptable cork from machine 1 is the sum of these 2 probabilities, which is 0.5328. Okay? So again, the probability that, let's just keep it up here, the probability that x lies between 2.95 and 3.1 is 0.5328. Okay, let's do the same calculation for machine 2. What's the probability that y lies between 2.95 and 3.1? Okay, that's equal to the probability that z is between 2.95 minus the mean of z, which is 3.06, divided by 0.05, okay, on the upper side. And here, 3.1 minus 3.06 divided by 0.05 here. Okay, so we can just do this calculation. That's just a z-score. That's just arithmetic. This gives us here the value negative 2.2. And up here we get 0.8. Okay, So the probability that y lies between 2.95 and 3.1 is equivalent to the probability that z lies between negative 2.2 and 0.8. Okay, we can go look this up in our handy dandy z-chart, and we get the value in between 0 and 2.2. What's this area? That is 0.4861. And here, the area between 0 and 0.8, that area, when we look this up, go down to 0.8 in the row and 0.00 in the column. That area is 0.2881. Okay, so the sum of these two probabilities gives us the probability that y is in between 2.95 and 3.1. Okay, that sum, which is 0.7442. So the probability that y is in between 2.95 and 3.1 centimeters is 0.7442. Okay, so what does this tell us? This says that the probability that we will produce an acceptable cork from machine 1, 0.5328. Roughly half the time, only roughly half the time, we're producing an acceptable cork from machine 1. Okay, this says the probability of producing an acceptable cork from machine 2, 0.7442. 3/4 of the time, we're producing an acceptable cork from machine 2. Okay, so this particular machine setting, this mean and this little bit higher mean, but smaller variability, okay, the mean is shifted a little bit greater than this one, but the dispersion is much smaller. That's a good thing for us, okay? It's allowing us to produce acceptable corks more frequently. Okay, so machine 2 is better for our purposes in meeting the specification on corks.